Hello, am I audible? Okay, we'll wait for some time before people joins. Okay. Maybe we'll start at 3:10. We'll wait till the people join.
एक साल में पर रिप्लेस हो सकता है। इसका पता नहीं होगा कुछ, आ तो नहीं रहा हाथ में।
थैंक्स भाई, मेरे लिए बहुत
यही रखो, अच्छा है कॉफी।
हाँ। Hello, 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 hello. Hello, are you able to hear me? Hello, I guess we'll start, right? So, yeah, I hope you all are there and able to hear me. So, can anyone tell me what has been done so far? Anyone? Yes, Tausif Khan or Nishant, Madhuri, Pushpa, anyone? Okay, ठीक है. Okay. So, Meti, maybe.
Good afternoon, sir.
Good afternoon, Chandini. Yes, Chandini, right? So, yes. Um, I mean, some people wrote that you have. I mean, so far floating point representation have been covered. Then BCD to uh, XS3 that has been covered. Any other thing? So, shall I start from the beginning? Will it help?
Yes, sir.
Okay. Okay. So maybe we can start from here, right? I think this is okay. Yeah. So you know, right, what are digital systems? So digital systems are systems which takes digital input, and they are of the form of zeros and ones. Okay, there are no other numbers except for 0 and 1. So how do you form 23 or let's say 75? You form this 23 with the help of a set of zeros and set of 1, which we call as binary number system. Okay, important. So this is what forms our digital systems, and it also gives out digital output. It is not that, okay, let's say you have a system, digital system, where you have input and output, all are digital first of all, and the operations that are going on inside, they are also digital. They are not analog in nature. So can anyone tell me what is the difference between analog and digital? Anyone? Yes.
Analog has continuous values where digital has zeros and ones.
Yes, exactly. So can you tell me one thing? So for example, analog can take value 2.345. So if I have a system which deals with -1, 0 and 1, can I call it a digital system? No, we cannot call it a digital system. It is a discrete system. Okay, this is important. So just hold on. Yeah, just let me check two things. Is it clear, this one?
Sir, your screen is not visible.
Oh, acha, that is the reason. Sorry, sorry. Yes, I'm very sorry. Yeah, are you able to see my screen now? See, I may need to get some answer because I cannot see if you are raising your thumbs up and all. So
Yes, sir.
okay, okay, thank you, thank you. Keep saying verbally, okay, or vocally, because or else I won't be able to keep a track of the chats and the emoticons. Okay, so digital system on this hand. Sorry, wait. Yeah, correct. So but you see, the problem is most of the sensors are analog in nature. Okay, so you need some kind of conversion from analog to digital. Let me reduce the line width. Analog to digital, right? You seem need some. So this is done by ADC. Okay, this is done by ADC. So you see that what are the examples of a digital system? Smartphones, mobiles, internets, routers. Okay, they are all are digital systems. But does it mean it does not have analog counterpart? Yes, it has. But most of the component in your system are digital, right? Okay, so similarly smart TV. So this is not important. So yes, so what you will learn here is you have this digital system designing, okay, how to represent any information. Are you able to see what I'm trying to write? You're able to see, right?
Yes, sir.
Okay, so yes, can you say this information very important. So information can be of analog nature, can be of digital nature, but whatever be the information, we have to represent that in a digital form. Okay, then we will learn about this Boolean algebra, logic gates and optimizations, then how the gates are important and can be classified as combination logic and sequential logic. Can anyone tell me what is the difference between a combination logic and sequential logic? Anyone?
In combination, we don't require.
No, I could not follow. Can you repeat?
In sequential, it requires previous memory.
Hmm. It is not previous memory. It is requires memory. The moment you say memory, it means it has got something to do with some previous values, right? So that's why it is called memory, right? So yes, you are right. So then how you combine this combination logic and sequential logic to do a system design, and finally what are the different ways in which you can implement a system design, either in synthesis or in FPGA, right? So forget this part. I hope you are following these books. These books are very standard books, very standard books. Hmm? Make sure you follow them, right? Especially this book by Roth, very good book. Okay. So these are the logistics. Yeah, so next we will understand what is a binary representation of a digital signal, right? This is important because the moment you say binary representation, it means that any signal can be represented only in two states, 1 and 0. Okay, this is binary, right? Now there are two states of, like for example, if you have two states of matter, black and white, and the clock hands can move either in clockwise direction or anti-clockwise direction, again it can be termed as 1 and 0, right? So this is what is called as binary system. Now in electronic system, this binary, whatever you are doing, that is up till the book or the pen and paper, right? What if you have to represent this in hardware? At that time, how will you represent? See, in hardware everything is represented in terms of voltage and current, right? So 1 represents a high voltage and 0 represents the low voltage, and sometimes 0 can also represent a high voltage and 1 can also represent a low voltage. But what is important to understand is when you say 0 1 1, you are actually referring to some states of the voltage, right? Not exactly the high voltage or a low voltage. So for example, if you have one bit, you can represent this in either 0 or 1 form, right? If you have 2 bits, you can have 0 0 1 0 0 1 1 1. Okay, So these are the number of bits. So what will happen if you have 3 bits? So you can also do in this way, that how many states it can take. It can take only 2 states. And what is the number of ways it can take the 2 states? It is 3. So total number of states will be 3, right? So this is important. And for n bits represents n states. Now you have 10 bits, 1024. 20 bits will be, so these are some numbers that you need to just keep memorizing. Okay, yeah, creating a digital signal from analog signal, very important, very important. So there is a process involved which is called quantization. Okay. Again, a very important thing, quantization. So here you see you have an analog signal which looks like this. Now you are first discretizing the values, right? You are discretizing the values, that from this to this the value is only 0. From this to, when the value is from this to this, the value is 0. When the value is from this to this, the value is 0. So this is the way you discretize the signal first. So any analog signal you first discretize and then you convert it into digital signal, right? Important. Yeah, so discretization in time and discretization in values. So see, most of the signals that you have, they are all analog signals. Most of the sensors that you have, the transducers, they all give analog values, and this analog values can be given to digital input, digital output, and finally analog output, right? So they're a good thing. So what are the advantages of digital systems? So they are very accurate. Okay, it can be programmed. See, analog systems cannot be programmed. Okay, so nowadays still there are situations where analog systems can be programmed, but most of the time analog system cannot be programmed. It is easy to maintain digital systems. Why? Because in analog systems you have something called errors, which increase or decrease over time. In digital systems you have only 2 states. Okay, so the chances of the error corrupting the whole system is very less, right? And then design automation. Okay, you can automate the whole process of design in digital, not very much popular in analog. It's an application. So if I have to so can everyone see my screen, this assignment 0 wala screen? Just hold on. Yeah, can everyone see my assignment 0 wala screen?
Yes, sir.
Okay. So can someone tell me what can be the first answer? Anyone?
10001.
10001. So let us click on this and see. Which of the following statements is correct? What do you think?
Analog system requires smaller silicon area.
Yeah, and what about this one, first one? analog systems are definitely faster than digital systems. Okay, digital system can never beat the analog system. That's for sure. They're always faster. It is not necessarily true. Okay. So how many bits are there in 1 KB memory?
1024.
1024.
In a 3 input NAND gate, if inputs are 0, 1 and 0, what will be the output?
1.
1.
Okay. Which is the following, which of the following is valid for hex numbers? Tell me. What do you think?
First, second, third.
Okay. Okay. Which of the following appliances have at least digital component?
All.
Okay. Which of the following is used to measure the size of a memory?
GB, KB, TB.
Flip flop is used to.
Store 1 bit data.
Okay. You tell me one thing. Why didn't you say do logic transformation? Because in T flip flop, you know, right? Whenever you give the input, the output reverses, right?
Yes, sir.
Then it also does logic transformation. So this question is not very much valid. Okay. So, anyways, but the main important thing is to store 1 bit of data. Which of the following is a universal gate?
NAND NOR.
Why they are called? Why they are called universal gates?
Because using those gates, we can design any gate.
Right. Wait. Yeah. Correct. 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 So, any other replacement? If I ask you to choose 2 gates, what will be the answer?
Can you repeat, sir?
For example, if these two options are not there, NAND and NOR is not there, which one should we select?
Maybe XOR?
No, I can choose multiple options. So you see, if NAND and NOR is not there, I can still select and not, right? Because with this I can make a NAND and then I can use it to make all the other gates, right?
Yes, sir.
So I mean, all options are there because NAND and NOR is there. So that's why you may select NAND and NOR, but mostly it is uh, you in fact can with a very careful with using multiple gates you can actually create any other gates. Okay. Now digital system design methods can be used to which one?
Automated control.
Okay, what about computers, calculators?
Yes, sir. Computers, calculators also.
Okay, what about hardware accelerators for machine learning? That you might not know, right? So yes,
Yes,
it
sir.
is possible, right? It is possible. So if we look at the
Sir, go to fifth question.
fifth question, yes. Anything you want to see?
8 is also in the hex value.
Yeah, but these two double O is not in the hex value, na?
Yes, sir. I didn't.
Hmm?
Yes, sir, I did.
You didn't see that, huh?
Yes, sir.
Okay, you are Chandini, right? Right, yes. So yes, I mean 8B, ADF, everything is fine, but double O is not fine. Right? So this looks all are okay. Let me see if I can check and submit. Yeah. So see, you can see right here that which answer went wrong. Tell me. You told 1024.
Yes, sir.
Why is it wrong? Because it says how many bits.
One bit.
How many bits are there in 1 kilobyte memory? So capital B is byte, right? So it is 1024
Yes,
into
sir.
8, which is 8192, right?
Yes, sir.
So that is one place. Okay. So maybe we can go to. Acha, how many classes has been? 2 weeks are over for classes. 2 weeks, right?
Yes, sir. This is third week.
Third week. Okay. So maybe what we can do is we can do this. Yeah. Can you tell me this one? Can you do in your copy and tell me which one is right? Then we will check the answers. Are you doing?
Yes.
Yeah. So those who have joined now, please do the first question. I'll also do it. I hope.
Sir, can you say the question, please?
Yeah. Are you not able to see the first question? Question one.
No, sir. No, sir.
What about others? Others are able to see the first question.
Yes, sir.
Oh, acha. Okay. Okay. Just hold on. Are you able to see now? Hello.
No, sir.
Still.
Showing that is presenting showing, but no picture.
Is it?
Yes, sir.
Yeah. So, are you able to see now? Not now. Still, it is not showing. What about others?
Yes, sir. Now it is showing.
Okay. Okay. Maybe there is a lag. That's why.
Okay.
Yeah. Yeah. Can someone tell me the first answer? Give me 1 minute. After 1 minute, I'll be back. Please be ready with the answer. Yes. Anyone ready with the answer? Anyone?
Four six eight seven five.
Sorry.
0.46875.
0.46875. I think this one 453125. How did you do it? For example, it is the value is 0.011101, right? This is the value. So this one is multiplied by 2 to the power 1, 1 is multiplied by 2 to the power 2, 1 is multiplied by 2 to the power minus 3, 1 is multiplied by 2 to the power minus 4, 0 into 2 to the power minus 5 plus 1 into 2 to the power minus 6.
6 is there, sir. Sorry.
Correct,
Left it. Yes, sir.
correct,
Yes, sir.
correct, correct. So tell me now. Tell me now. What should be the answer?
0.453125.
Yeah, right. Okay. So, okay. Second question.
C, sir, C.
C. Yes. Okay. What about 3? Question 3 is tricky, huh? Just read the question properly. Then you answer. Yes, Pushpa, I'm not able to hear you. But you can tell. everyone, instead of writing in chat, if you can just speak it out, it will be very easy for me to understand, right? Yeah, anyone? Question 3, it is very tricky, very interesting. Just tell me, give me an answer, true or false. It is a very tricky question and very interesting also, huh? Question 3. See, okay, let me help you. Should I do this question, question 3? Will it be helpful? Hello, are you able to hear me?
Yes, sir.
Okay. So, you see, whenever you have a signal, okay, just hold on. ठीक है, you do sampling, discretization in time, which is called sampling, and then you do discretization in amplitude or space, which is called quantization. But what the question is saying is, if you see carefully, it says discretization in time is called quantization and discretization of values called sampling. So that's why it is a false. Okay, if it had said discretization in time using sampling and discretization of values using quantization, then maybe this was right. Okay, but this is false. Did you understand?
Sir, can you repeat?
Yes, yes. So you see that, just hold on, someone is joining. You see that whenever you have some kind of signal, okay, you first sample the signal, right? So this is like you have continuous time and you are discretizing the time. Now this operation is called sampling. Now you have something like discretization of values, which is called quantization. So analog to digital conversion has got two steps. One is sampling and quantization. Sampling is discretization in space or in time. Okay? Quantization is discretization in values. But what the question says, discretization of time is called quantization and discretization of values is called sampling. So that is the place where it has gone wrong, right? So that's why the answer is false. Is it clear now?
Okay, yes, sir.
Yeah, yeah.
Thank you, sir.
Okay. So question 4, the smallest integer that can be represented. Yeah. 8-bit integer, 8-bit number.
Sir, 128.
Correct. Minus 128, na? Minus 128.
Yes, sir.
Okay. So what is a binary representation of 0.6 with precision of 8 bits?
A, sir.
Which one?
A.
A, right? Sure.
Yes. Yes, sir.
Just let me check. Very good. Yes, it is A. So we'll submit. Yes, looks like everything is correct. Right. So we will do something of. Yeah, please.
Can you explain question 4, sir?
Yeah. So in question 4, you have this 8-bit in 2's complement representation, right? So what happens in digital system, to represent negative numbers, you employ something called 2's complement. So in 2's complement, whatever you do, let's say you have a 8-bit number 1 1 1 1 1 1 1 1. This is the sign bit. It is not exactly the sign bit, but looking at this MSB bit, you can understand whether the integer is represented in 2's complement form or not. I mean, whether the value is negative or not, that you can find. And if it is said that the value is represented in 2's complement form, then what you can do, you can take 2's complement of that number to find out the negative number. Now the range of 2's complement number is from, let's say the number of bits are n, so it is from 2 to the power n minus 1, which is, let's say 8 bits, no? Sorry, to the power 7, sorry, 2 to the power n minus 1 minus 1. So these are the range of numbers that can be represented in n bits
Okay, sir.
2's complement form. So here it is said that n is 7. So if n is 7, and what is the least value of that integer? The least value is the most negative value. Okay, most negative value, and the value of this is 128 minus. Is it clear?
Yes, sir. Clear, sir.
Okay, great. Yeah. So this one is fine. Right now I'll share something again. Yeah. Are you able to see the screen?
Yes.
Yes, sir.
Yeah. So what is the answer to the first question? Oh, acha. These answers are given, is it? This is very bad. Okay. Why the answers are given? ठीक है. Just hold on. Are you able to see my screen?
Yes, sir.
Yes, sir.
Does it say week 2 assignment 2?
Yes, sir.
Okay, yeah. Can you answer the first question?
0100 100.
Right. Anyone who is having difficulty in understanding, please let me know. Okay, please let me know. Yeah. So this 25 in XS3 BCD code.
0101 1000.
0101 1000. Anyone who had problem in understanding, please feel free to stop me, okay, and tell me that okay, you did not understand this.
Sir,
Hmm?
I have some another doubt, not this one.
Hmm?
I have another doubt that access how to convert access 3 to gray code.
You have this I mean there is a
In
digital
that
huh?
in that
Just
last assignment it was there.
hmm,
It came wrong.
just hold on. I think it should be there. Just hold
Week
on.
1, sir.
Oh, I am not supposed to discuss.
That last question.
No, it is in your current assignment, no?
No, sir, that unit is over. It's
No,
already
sir, it is
submitted, sir.
No,
previous one.
yeah, I understand, but what I'm saying ke there is a strict rule that I cannot, you know, discuss about any of the assignments. I think so. Normally, other people are discussing.
Sir, you can't explain that exact question, but you can take some other example and you can explain, sir.
ठीक है, I can do that.
Okay, sir.
ठीक है. See, the normally na, for example, you know how to convert from one state to another. I mean, are you aware of that?
Yes, sir.
Okay, so normally how see XS3 to gray code, one way is you subtract 3, okay, from that XS3 value and find out the binary value. Okay, and then that binary value convert to gray code. You know how to convert to gray code, right? By
Yes, sir.
zodding the bits.
Mm.
So you can do like that from XS3 to gray code.
Means from XS3 to binary, then binary to
Gray
gray.
code, yes, yes. I mean, for example,
But
if
we did, but it was not coming the correct answer.
acha, maybe I'll check.
Okay, sir. But in that YouTube somewhere I saw there one table was there. In that table, he was solving with that K map of something like that, and then he got.
See, yeah, yeah, true. The see, but that is a long process. Okay, see what they do. I'll tell you. Oh, you are not able to see my OneNote also, na? You should have told. Just hold on. Because when I was explaining this complement and all, I was explaining with this writing. Were you able to see? No, right?
Yes.
And this part also, I think so. You should have told. Okay. If you are not able to follow something, let me know. Okay. So yes. So you see in XS3, let's say you give something here, which is XS3, and you get it gray, right? So what happens? Let's say XS3 starts with what? 3, right? 0 1 1, then 1 0 0, 1 0 1, like that. So this is the binary number system from 0 to 9, let's say. Now gray code on the other hand starts with 0 0 0. So you know, then what is this? it is next is 0 0 1. Okay, write this. So what they are doing, so this is my input and this is my output. So when you know the input and output, you can make a K map, right? So let's say this, for this set of inputs I have this set of outputs, again for this set of inputs I have this set of outputs. So for each of the outputs, so let's say input output I1 I2 I3 O1 O2 O3. So right now you can draw Carnot map, and for O1, so for O1 you have this combination of I1 I2 I3 which will give you some set of O1. For O2 you again draw Carnot map and solve. For O3 you again draw Carnot map and solve. Okay, for the set of inputs I1 I2 I3. Okay, so when you do this, what happens is you are generating a specific circuit for O1, specific circuit for O2, specific circuit for A3. So that is a circuit level description of XS3 to gray code. But when you are trying to do it in pen and paper, you don't have to worry much about the circuit. So got it?
Okay, sir.
So yeah, you don't have to bother about the circuit part, at least when you are doing, when you are trying to solve problems or MCQs, right? Yeah, so yes, can anyone tell me this, converting decimal to single precision floating point number? So how do you approach a floating point number? You have minus 1 to the power sine into 2 to the power exponent minus bias into 1 plus mantissa. Now you say that you have to represent 1.5 in this format. So the one way would be you represent 3 divided by 2 into 2. Okay. Now this is same as this is given as 2 to the power minus 1, and then you have 6, right? So same as 2 to the power minus 1, this is 1 plus 5, right? So this is the way you do. So the 6 and even whenever you are trying to do, so this minus 1 can be called as, since you have a bias of exponent minus bias is minus 1, so exponent is it is 127 for single precision minus 1, so exponent is 126. So what is the equivalent of 126? It is 3F and then C. So So it should be amongst this. Definitely either 3F4 or 3FC. Huh? So mostly it will be, so it is 1.5, so it is 3, so it should be 3FC like this. Okay, but are you aware of this floating point representation and fixed point representation? Has anyone taught you floating and fixed point representation?
Yes, sir. Floating point we know, but that fixed point,
No,
I
not
don't.
fixed point, is fixed point, no need. Floating point.
Floating point was done, sir.
Okay.
But it is one page answer. Any से मतलब shortcut कुछ है?
नहीं, there is no shortcut as such, but I can give you some YouTube videos which can actually deal with shortcuts. So okay, so for example, in the YouTube, if you search converting a floating point number to equivalent decimal number, you will get some shortcuts. But see, more than shortcuts can be used for solving in problems, but don't use shortcuts for, you know, uh, doing projects. Okay, it will cost you. So maybe this floating point representation we can do next week. Okay, and maybe we can are there any other TAs which are actually dealing with the digital system? Hello? Hello?
Yes, sir.
Yeah, are there any other TA or any other people who are dealing with digital system? Are they solving the doubts?
Yes, sir. They've solved few questions. Like they have some questions in their PPT. They solve those questions.
Okay. ठीक है. So maybe what we can do is we can meet next week, and then see. I would suggest that if you have any questions, please bring them out in the sessions. These sessions are actually meant for, like, whatever questions you have, we will try to answer that. Got it? So study and bring out questions. Whatever. For example, if you don't understand any concept, just let us know. So that way things will be easier, and you will also feel the need to attend these sessions, because right now the situation is you will get all the questions somewhere there in the internet. So practicing questions is not a problem. Okay, but what is important is to, you know, uh, to understand the concepts. So make sure that you understand the concept. So next week what you are going to do is just study some portion and then come back with some questions. It will be, then we can have a discussion, right? Is it okay? Okay. Yeah. Fine. I think we can end the session. Hello?
Yes, sir.
Yes, sir.
Yeah. By the way, you can again join at 5 o'clock. I can keep this meeting on. You can join at 5 o'clock because I'll have another session at 5 o'clock. So if you want, you can join at 5 o'clock. We can solve some more questions.
Okay, sir.
Okay, sir.
Okay?
Okay, thank you, sir.
Yeah, thank you.
Same topic, sir.
No, I mean, whatever we have done, after that we can add some more topics and solve questions.
Okay, sir.
Yeah, so you join at 5 o'clock. That is better.
Okay, sir.
Yeah.